Okay? I'm recording everything else that I'm doing on the computer. And I'll post this video on StudyWiz for you. Okay? So we have this. So now we have our data. Obviously, when you put this into your Word file, are you going to clean it up some? Yes, I'm just worried right now about the actual processing. We have everything we need. Now, let me quit some other programs. Okay. Well, it has to be due pretty quick because I need to get it graded. But we'll see. I might let you email it to me. And again, let's go back to Zod's question. Do we need to use Logger Pro? You don't have to, but this is why Logger Pro is so beautiful. Our x is our independent variable. What did you change on purpose?
The weight.
So the pulling force, right? So the force. Newtons. Okay. Let's go back to Excel. I take my force. I copy that. I go here. I paste. What is your y going to be? Acceleration. And so again, it's y, it's y. I go here. I say acceleration, short name A, units, meters, seconds, and I can get superscript minus, and then a superscript 2, and it's there. And it's here for you. I go here to my acceleration. I copy. Oh, good job, Excel. Oh no! Bad job, Fleming. He didn't save all his hard work. I broke the first rule. Okay. Okay. Why would you want to do that? Tell me why. Here's Smart Girl. Because it will give you, it will directly give you the gradient. And the gradient will be directly mass. That's fine and that's good. Okay. I would say, and that's perfectly acceptable, that would not be marked wrong. I would say though, as a general rule, you always put what you change on the bottom or what you measure on the side. And if you do that, you're going to have to realize that the gradient is not your mass, and it gives you the extra step of thinking, and you'll get used to the thinking in the future. Okay? Oh, I did something wrong here. Oh, I pasted the same thing because of that horrible Excel. Will it recover? Oh, yes. Let us save. We lost our save. Okay. We lost our uncertainty and acceleration, but we got everything else, so that's okay. Equals what? Acceleration times brackets R and R 0.005 divided by R plus 2 times uncertainty in t, which is 0.01 divided by t, close brackets, fill down, and then toolbars, formatting, and save. And so let's take our acceleration and put it in here. Good. So it gives us this graph. Do we want to connect the dots?
No.
No, so we're going to double click the graph. Remember you went through the tutorials. We double click the graph and we turn off connect points, but we want to turn on pointers. That gives us the big circles.
You need the error bars too.
We're going to do the error bars as well, yes. And now let's give it a title since we're here. What's our title going to be? The general rule is always y versus x. So it's going to be acceleration versus force for a stopper. What? What was the stopper doing? Stopper in circular motion. Circular motion. Okay. Horrible scale, isn't it? How can I get nice, beautiful scale? Up here. This shows like a scale, doesn't it? And it's an A. I'm going to click that. It's going to auto scale. And it gives me a nice scale, but there's a problem. Quite often I want it to go to 0 and this one doesn't. So I actually have to double click. I'll bring this up so you guys can see a little better. Let's go here in the corner. So is that better for you to see?
No.
It doesn't go to 0, so I'm going to double click the graph. I'm going to go to axes options, auto scale from 0, and auto scale from 0. And now it does it from 0. Okay, so you have your graph. Now we need to put on our uncertainties. Let's go back to our table. Is our uncertainties for force all the same? Are they all the same? Yes. Let's reduce those decimal places. Oh, good boy, Excel. Formatting, boom, boom, boom. So each one is basically 0.1, which matches our data here, which is nice. Okay, so I double click on force, and I go to options, and I want error bars. I want to use a constant, and the constant I want to use is 0.1. And it draws little tiny ones on there. So under your graph, what do you have to physically type?
Too small to see.
Error bars in force are too small to see. You need to say that. Okay? Let's try acceleration. Acceleration ones, they're different. Okay, so I'm going to make this graph a little bit smaller here. I'm going to extend this out a little bit. I'm going to go data, new manual column. I'm going to call this uncertainty in acceleration. Uncertainty A and meter seconds minus 2. Done. I'm going to go back to Excel. I'm going to copy my uncertainties. I'm going to paste them in this column. So I'm going to double click now on acceleration, error bars. I don't want a fixed number because it's different every time. I want to use a column. Which column am I going to use? Uncertainty acceleration. And we have them. Notice the sizes are different because they're different. Now you have to ask yourself when you look at this data, there's at least one point that's really bad. And we have to decide, is it this point that's really bad? Is it this point that's really bad? Is it that point that's really bad? Or, well, those are probably the three contenders for the worst points, right? Which point do you think is really, really bad? I'll label them for you. A, B, C. Which one's really bad? B because it's really high, right?
And then it looks like it's like curving, and then it kind of like go up.
Okay. So it looks like you're saying the graph is curving. What else is the graph like? So if the graph is curving, B is really bad. Okay. What else could the graph be? Straight line. and C is really bad. So you have to make a decision. Which one's really bad? I probably think C is pretty bad, because doesn't the straight line make more sense? That's what we're expecting. Okay? So we've got that. So, who can remember from your tutorials how to get a straight line? Let's try this one. This one says statistics. Integral. Linear fit. That's a good one. What's wrong with that? The C's included. But we don't want to include C. I'm going to take this and I'm see that little thing? It's saying which points to use or not use. Also look at your y-intercepts. See down at the origin. It's changing where it's going to. So you might think, what's the best? Obviously, should you just take 2 points? No, you want most of them. We want to ignore C. You're lucky that the one that you want to ignore is your last one. So it makes your life easy. And that's done for you.
Oh, well, what if it's in good?
Ah, thank you. Excellent question, sir. But before I answer that question, you guys know you want the gradient. And look, it even gives you the units of the gradient based on the units that you added here. So again, I think this is a whole lot better than Excel. Good news as well, I wasn't sure a few years ago if you were allowed to use the gradient from the computer, but you are. Okay, so before I told my students, I'm not sure if you can use this, maybe you have to calculate it, or we had to kind of fudge it a little bit. But it says in the syllabus, or not syllabus, in the book, that you're allowed to use the computer generated gradient, as long as you think about it.
Do we have to draw it on the graph?
No, you're allowed to click the button.
Okay.
Okay? But you have to think about it. If you just click the button and go like this, you didn't think about it. You just click the button. You have to click the button and think. Okay? So we have that. And then you're going to use this somehow. Okay? You're going to use that somehow. But here's the next thing. Let's look back at our blue pages. What else do we need? We need max-min lines. Okay? We need max-min lines. But before we get to max-min lines, let's answer Zaw's question. What was your question, Zaw?
How do you not include one center in the center?
Okay. Let's imagine that this point right here was a bad point. Can you agree with that? Let's pretend he was. He's reasonable, right? He's not right on the line, but he's reasonable. Let's imagine he was a bad point that we wanted to ignore. I got good news and bad news for you. Here's the good news. We say strike through data cells. And watch the line. The line will change. The line changed, didn't it? What's the bad news? The point is off the graph. Do you want to print that graph off with that point not on the graph? No. So there might be a better way, but I don't know a better way yet. I'm going to show you my solution. Okay? Keeping in mind that everything that you're seeing right now is being videotaped. And this will go up on StudyWiz. Okay? Here's my solution. We need to add that extra point there, don't we? And we know, but we don't want our line to include it, so we're trapped. Any ideas what we can do to add another point? I'll give you a hint. I made this wide for a reason. Add another column. Blah. Okay. And add another column. Actually, we only need, and I'm going to call this 185. And what's its uncertainty of 185? 9. So I can just go here and say 9. Okay, but the graph didn't graph it, did it? Okay, so you can do a few ways. I can put this on the graph by dragging it over. And, oops, I'm missing. back. And let me see something. Okay, I want to get rid of this guy. Or we might need to add both of them actually. That's my click. I did this the other day. Strike through this one. Now, I guess you do have to do both. You strike through, but then you new manual column blah 2. And the one I want, oh, let's get rid of all these then. 3945.8. Sorry, I did this the other day and it worked fine.
You didn't assign it axes?
Sorry?
You didn't assign it axes?
Well, I'm assigning it here on the Y. So you can say I want to put acceleration and I want to put blah. I want to put both. Oh, I know why. Okay, it's on the same line. What we want to do. So let me click it once in a while. I'll just put it over here. This might be 8 right there. Okay, so I don't need this one. You just need the matching X with the Y again. And we'll draw our straight line. I only want the acceleration. I don't want a straight line for blah. Okay. So that's how you do it. But I've got this name over here. I don't want blah there, do I? So I'm going to go more. And I'll actually change its name to acceleration. But I think I can't get the superscript now. That's okay. I'll have this as a -2.
Is it wrong if we can't do that? If we put the arrow?
Yeah, then actually you're right. I should put the no, that's fine because they will. Okay. Yeah.
When we print this graph, it's always only print the black line, not the extend the little dots. I mean, it doesn't print like this.
Okay, watch this. Okay. No, that's an excellent question. I just thought of the answer, but I figured that's what the answer would be. Okay, so we have that. Now I go copy. I go to Pages or Word. And I go paste. Okay, it's there and it's done. Ah, max min lines. Okay, I'm going to save this because there's been lots of work on this. We're here. Okay, max min lines. So I'm going to click this to get another line for acceleration. I'm going to ignore this last one again. Actually, no, the best way for you actually is to go straight here. Click this button instead. It brings you into here. You know you want a linear line. You say try fit. And then you can play with it. But look at it, it's moving way too much, isn't it? It changes from 16 to 6. So how can I make it change less? This button here. I want to change by, let's say, 0.01. Let's try that. That's still too much. 0.5. And then I can also change the y-intercept. That's changing by too little. Let's just make that 1. So I make a relatively steep line. And I get the maximum. And then I have to do same thing again. I say linear. I say try fit, so that's the best one. I go with, I say 0.005. And this one I want that's moving too much still. 2, let's say. What do you guys think? Is that okay there? Alright, it's okay. There you go. Now for organizing these little boxes, where should the maximum one be? On the top, in the middle, or down below? On top, because the max, so I think this is our max actually. So our maximum we might put there. This is our minimum, and here's our best.
But isn't that going to like block all the points?
Okay. Okay. So you got very good questions, but again, this program is so amazing, it has lots of good answers for us. Okay, so you got that. So now let's take another copy. Let's go back into here. Let's get rid of this one. I want the max mins. I also might say text box max. And I want to put the text box. This one. So I might put the word max there. I'll copy the text box. I'll put another text box. Where did he go? There he is. Over here, I'll label it min to make everything clear. Then I might label this one as best. Underneath, you have all this big mess of numbers. So you should put your information into explain lines of best fit. Then you have max. I might have best fit, best, max, min. So again, looking at our blue pages, they have this here. So the computer generates the best fit line with the gradient of that. Then they explain how the gradient, at the sample calculation, getting the resistance. In this case, you can show how the gradient relates to the mass. Then they have the maximum, and they find the maximum resistance, the minimum, and the minimum resistance. And then they show what the uncertainty is. Okay, so what you do not have to do you don't have to add up all your uncertainties. That will come from your max-min line, so that makes your job a little easier. So the overall resistance will be the best, plus or minus your uncertainty that you get from your max-min lines. And again, this is not Mr. Fleming making extra work for you or crazy work for you. This is exactly from the IB. This is what you guys need to do. And I want to make sure, and we're spending lots of time, aren't we? Okay, this is a big, complicated data process, so we're spending lots of time getting this ready for you. Any other good questions?
Do we have to make a separate graph for the first line and the two other lines?
I mean the max-min lines?
Yeah.
No, here's the example from the IB, max, min, best. And here is exactly, Melissa, this is yours.
Yeah.
That's yours. Okay, advantage you guys. You know exactly what yours should look like. Okay. At the end, actually let's go back to here. Conclusion and evaluation. You have to compare to the real value. Okay. So you can find the uncertainty of the real value with your percentage discrepancy formula, the experimental minus theoretical divided by theoretical multiplied by 100%. But also you can just say, based on what you did here. So let's say you get a mass. You get a mass, and you find your gradient, then you realize how the gradient relates to mass, and you get a mass equal to 27 grams. And you do your max and your mins, and this one is 30, and this one is 26, let's say. Okay. Your uncertainty will be the max minus the min, so 30 minus 26 divided by 2. That gives you uncertainty of 4 divided by 2 of 2. Right? So your answer, therefore, your mass plus or minus the uncertainty of mass is the 27 from your best, plus or minus what you got here from the calculation. You got uncertainty of 2, plus or minus 2. So you're allowed between 25 and 29, okay, from the experiment. And your real value, what was your real value, Melissa?
I'm not sure. I didn't bring my phone today.
Okay, sorry, Joe.
It's 20.3.
20.3. Your real value is 20.3. Are you within your allowed uncertainty? No. Okay, so then what do you have to do? You need to explain that. Okay. And you say whether or not the form, so again, you have to talk about your data, talk about various things. Okay. Read these points here, because it gives you examples of what you could say. Again, not for our lab, but it'll give you ideas of what you could say and what you should say. Okay? Also, if you get larger error bars, you get larger allowed uncertainty. So looking back at your table, you said your uncertainty was 0.5 millimeter, right? But that's, oh, 0.5 centimeter? Yeah, you're right, I see 5 millimeters. Okay, that's reasonable. But you could also justify a larger uncertainty. Okay? So this is what you need to do. Again, in your table, once you have your table in Word, so we take your table, I'll just go like this for now. No, it's just something weird right now, so I'm going to go fast. Good enough. You would not do this, but let's say you did. Okay, so you have your table. What you should also do, especially justifications of uncertainties. uncertainty. That's where, let's say you want to go higher. Maybe somebody said a centimeter. Maybe somebody even said a centimeter and a half. Can you justify that in this lab? How, yes or no? Like, that's pretty big, isn't it? To measure on a ruler, to be off by that much using a ruler?
You could, because the string is sort of elastic when you pull it.
Okay, so you talk about elasticity of the string, so it can change. You can say that when you're spinning and you grabbed it with your thumb and you put all that process, it's not just the final measure with the ruler, it's the uncertainty in the whole length. So you need to explain that. Blah, 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 blah. Does that make sense? Okay. Any other questions? Girls, any other questions, you two?
If we have like lots of tables, can we put them like underneath each other?
No, you have to, okay, no, your tables have to be fundamentally redesigned. All of this should be in one table. Like, you don't have set 1, set 2, right? You should have this number next to this number next to this number. You should have all of this ones together, right? That mass with all of these times and all of these lengths, and then the next mass all in one. Does that make sense? Yeah, on this lab, because there's so much different data processing, you want 2 tables. But you should not have 5 data collection tables. And where should this average be? All right, maybe over here on the side, but you probably don't, remember I explained yesterday, you probably don't want to find an average of all these, 134 to 104, because it changes depending on the time. So at the end I said you probably want to find your average acceleration, because all the accelerations for all of these should be close. Let me see. I'll take it this way. First, I want to stop the copy, the movie. Screen flow. Come on, where's screen flow? There it is. And stop recording.